very interesting and conceptual problem of number theory, which is based on theory of congruence. Okay, and the problem from ISI B Stat entrance exam, and the problem is for any positive integer n and I this is equal to 1 2, let fi n denote the number of divisor of n of the form 3k plus I. Okay, that is if I equal to 1, then it is of the form 3k plus 1, and for I equal to 2, then it is 3k plus 2. Define any positive integer n, f of n is given by f1n minus f2n. Okay, and find the value of f of 5 to the power 2022 and f of 21 to the power 2022. So we have to find the value of f of, we first find 5 to the power 2022. This is given by f1 5 to the power 2022 minus f2 5 to the power 2022. We first find this value. Now what is f1 5 to the power 2022? f1 is given by this. f1 means number of divisor of 5 to the power 2022 of the form 3k plus 1. This is the meaning of f1. Okay, and similarly the meaning of f2 is the number of divisor of 5 to the power 2022 of the form 3k plus 2. Okay, to find the divisor of the form 3k plus 1 or 3k plus 2, we use here the concept of congruence. If we write that a congruence to 1 mod 3, okay, that is when we divide a by 3 and getting the remainder 1, then we say that a is of the form 3k plus 1 and similarly a is of the form 3k plus 2. We use these two concepts here. Now we first know that the divisor of 5 to the power 2022, which are given by 5 to the power 0, 5 to the power 1, 5 to the power 2 and 5 to the power 2022. We here from 5 to the power 0 we get this 1 and this is n, because this is the total number, and here it is said that including 1 and n. So we have to test these two numbers also. Okay, now 5 to the power 0, this is congruent to 1, obviously 1 if we divide by 3. So we write this. Now 5 to the power 1, this is congruent to 2, this is mod 3, because 5 is divided by 3, then leaves the remainder 2. Now 5 square, this is congruent to 1 again, because 5 square means 25. We divide by 3, then we get the remainder 1, and this is mod 3. And similarly, if we test 5 cube, this is congruent to 2 again, mod 3. And from this serial, it is clear that if we write here an odd power, then we get remainder 2, and if we write here even power, then we get remainder 1. So this divisor is of the form 3k plus 2, but this type of divisor is of the form 3k plus 1. So we have to count first the divisor of the form 3k plus 1 and divisor of the form 3k plus 2. Okay, if we count from 1 to 2022, 5 to the power 2022, this is obviously 1 mod 3, because this is obviously 1 because this is even. If we count all the even power, okay, then we get the even power out of 1 to 2022 is 2022 by 2. This is 1011. And if we count the odd power, then we get also 1011. Okay. Again from this term, we get another remainder of the from 3k plus 1. Sorry, another divisor of the from 3k plus 1, because the remainder is 1 also here. Okay. So this type of remainder, if we take even power, also 0 power gives this type of remainder. So here the number of remainder is plus 1, so 1012, and here 1011, right? So we get the difference, or we get the value of f of 5 to the power 2022 is given by f of 5 to the power 2022 is given by 1012 minus 1011. So this is 1. Okay. So our first answer is 1. Now we test for the second one. Here the number in this is 21 to the power 2022. This is not only the prime power. We first write it by prime power. This is 3 to the power 2022 into 7 to the power 2022. Okay. So the divisor of this term, that is the divisor of n, is of the form 3 to the power a into 7 to the power b. Okay. Here a and b are, this is less equal to 0 and less equal to 2022. Right? These are the divisor of 21 to the power 2022. Now if we take a, this is equal to 0, then the divisor is of the form 7 to the power b, where 0 less equal to b less equal to 2022. But if we take a, this is greater than or equal to 1, okay, other than 0, then we get the divisor of the from 3 to the power a and 7 to the power b, and this is obviously congruent to 0 when we divide it by 3. Okay. So in this case we cannot find, or we cannot get the divisor of the form 3k plus 1 or of the form 3k plus 2. So we delete this type of divisor from our imagination. Okay. Now we consider the divisor when a equal to 0, that is 7 to the power b type divisor. Now we get 7 to the power 0, this is congruent to 1 mod 3. 7 to the power 1, this is also congruent to 1 mod 3. 7 to the power 2, this is congruent to 1 mod 3. Okay, and all of them are leaves the remainder 1 up to 7 to the power 2022 when we divide it by 3. So we get the total number of divisor of the form 3k plus 1. This is given by 2022 plus 1. This is 2023. Okay. And we cannot get any one of the remainder of the from 3k plus 2. So our answer is this is f of 21 to the power 2022. This is given by 2023 minus 0, because the second term like this, if we write here, this is 21, this is 21, and this is also 21. Second term is 0, that is the remainder of the form 3k plus 2, and the first term is 2023. So our result is 2023, and that result is 2023, and the first result is 1. Okay, very interesting and important problem from number theory. Thank you for watching.